So today we'll be talking about linear equations in Algebra 1. Linear equations are basically where you have a coefficient, a variable, and another number. That could be any number. It could be positive, it could be negative. It's any rational number. So this is a variable. X can mean anything basically. It could be 1, -1, infinity. It doesn't matter what. But what we're trying to do is we're trying to solve for x. So how do we solve for x? Well, let's start with something easy. So let's do the equation 5x is equal to 12. What is x? Well, we will divide each side by 5 and get x is equal to 12 by 5. Many of you are asking, why are we writing in improper fractions? Our school taught us how to make it in mixed fractions. Well, in Algebra 1 and any grades above, most, if not all, teachers require you to put it in an improper form. So, while this is theoretically correct, it will get points off on most tests because teachers are looking for improper fractions since it's simpler to write with. Okay, so now let's go on to multi-step linear equations. We got 5x plus 17 is equal to 29, let's just say. So you'll minus the 17, so you make from this side, and you also minus the 17 from this side. This is 9. So you get 5x is equal to 12. And x is equal to 12 by 5. Make sure to also box your answers to make it easier for your teacher. Okay. The main difference between just doing 5x equals 12 and this is that this is multi-step. First, you do the subtraction on both sides. Then you do the division. That's why it's multi-step. Okay. Next, let's do another example. So we're gonna do 2x plus 96 is equal to 64. So let me pull up the calculator real quick, because I cannot do 64 minus 96 in my head, but be 64 minus 96 is negative 32. 2x is equal to negative 32. So you will divide by 2 on both sides, and you'll get x is equal to negative 16. And this is one of many examples where x will be negative. Now, linear equations could have some linear equations have one solution, no solutions, or infinitely many solutions. An example of infinitely many solutions will be 2 multiplied by 5x minus 8 and 10 multiplied by, wait, okay, this is so long, sorry, So you can get, let's just say 5x plus 3 is equal to, let's just say 2 times, or 1, let's just say, actually this would be good practice to use fractions, so let's delete that. We can zoom in a little bit and we could say 1 by 2, 10x plus 6. Oh my God. Okay, so we'll get 5x plus 3 is equal to, so since this is multiplied by 1/2, we'll multiply by 2 to 1/2. And we have to also multiply by 2 here, and it's 10x minus 6. 10, okay, x minus plus 6. So the 2 and 1/2 cancel, become 1. So this should become 10x plus 6 equal 10x plus 6. And if you cancel 10s out, you'll get 6 is equal to 6, which is infinitely many solutions. Now, let's go to an example where no solutions are available. For example, 5x plus 6 is equal to 5x minus 3. Let's just say that. So you can cancel the 5x out because they'll just become 0. So you get 6 equal to negative 3. Well, is 6 equal to negative 3? No, right? So this will be no solutions, or no real solutions, you can say. Next, we'll do, as you can see, we did many one solution problems. 5x plus 2 is equal to 3x minus 4. That's also one solution problem. So it really depends on, one solution problems are usually the most common. So yeah, and we're going to do one more type, and then we'll go to graphing. So you go to 5x plus 2 is equal to 3x plus 7. Oh, let's do 3x plus 8. So we're going to take the 3 here. It'll become minus 3 now. So it'll be minus 3x. And we're going to take the 2 here. It'll become minus 2. So you get, what's 5 minus 3? 3x. No, 2x, sorry. 5 minus 3 is 2x. So sorry for that mistake. 2x. Take the 2 here. You'll get minus 2 sub 8 minus 2 is 6. So you get x equal to 3. Okay, this only has one solution, and it's a different type of problem where there's a linear equation on one side and another linear equation on the side. Okay, let me just do graphing real quick. Let me just get some graph paper real quick. Let's look up the graph sheets. Maybe that'll be better. Oh my god. Okay, let me just graph sheets. Please give me a good one. I mean, there's not a good. Okay, but let me see what I can do here. graph paper. Let me see. Okay, this can do for now. Let me draw our origins real quick. So, huh? Oh my god, what happened to the thing? It becomes so thin. So, okay. So just say our origin is right here. You know what an origin is basically where the x-intercept, y-intercept intersect that. We assume, and let's just say we have a equation 5x plus 3. This 3 is actually the y-intercept. So this is the y-intercept. So which is equal to 0, comma 3, which we're gonna plot. Let's just say, uh, let's say this is our origin. So 0, comma 3. So 0, 3 is about right here, right? So let's point that in red. That's the y-intercept. And with 5, it's okay for the slope. It's basically we could do rise over run. So rise over run, where where the denominator is run and the numerator is rise. So in this case, 5 by 1, which means when you rise 5, you basically go up. When you rise 5, you go forward 1. So let's just say rise 5. So 1, 2, 3, 4. Let the graph a bit bigger. 3, 5, 1. And we could draw the graph so you could say the other way. So 3, and we could draw a different one. So basically, it goes something like this. Is how the graph will go. It goes something like that. I don't know if you guys can see it, but there we go. Basically, this is level 5. We'll talk about how to graph linear equations in more detail next class. Anyways, bye.